Okay, today we're going to talk about redox. And guys, redox is where we're talking about reduction and oxidation. And so whenever I was gone just a couple of days ago, y'all had watched a couple of those videos. Some of y'all said that actually assigning the oxidation number was pretty easy. Some of y'all are having a hard time, so I'm just going to recap it really, really fast. So there are a couple of rules that you need to know. Okay, oxygen, almost always. So hydrogen almost always is going to have a +1 charge. Okay, the only time that hydrogen would ever be a -1 charge is if it is bonded to a metal. If bonded to a metal. Okay, so really fast, because this came up yesterday, let's recap. Where are the metals on the periodic table?
To the left.
To the left of the metalloids. Where are the non-metals?
To the right.
I didn't think I had to recap that in an AP class. All right, so hydrogen, almost always a +1. If it is ever bonded to a metal, then it would have a -1 charge. All right, oxygen, almost always a -2. The only time it would not be a -2 is if it is bonded to a hydrogen to make peroxide. So the exception to that rule is if in peroxide, which is like your H2O2, hydrogen peroxide, it would be a -1. Okay, fluorine. You may remember what fluorine was.
-1.
Always, no exceptions, a -1. Good. All right, so when we do these redoxes, you always want to look for hydrogen and oxygen first. Hydrogen and oxygen are going to be on most of your compounds. So you try to do those two first. You do hydrogen before you even do oxygen. So you have to do those two. If I am group 1 or group 2, group 1, guys, if I look at the periodic table, group 1 has 1 valence electron, so what is the charge?
+1.
A +1. And for group 2, it has 2 valence electrons, what would the charge be? A +2. And those are pretty much almost always spot on. Very rarely would those ever change. So it's pretty much spot on. Group 1 is a +1 and group 2 is a +2. Anything else, guys, they can fluctuate. They can change. So group 1 will be a +1 and group 2 will be a +2. All right, so let's work a couple of problems really fast. Let's do, let me look at a couple of examples.
Beth,
Yes,
do you have Abby Bailey?
yes,
Can you send her to sign out?
on our way. Okay, so another rule, compounds will always have a charge of 0. So basically, whenever we have a compound, you've got your cation, they're going to give up electrons, your anions are accepting electrons. So when we do these oxidation charges, we're going to say compounds are always going to have a charge of 0. Now ions, guys, your polyatomic ions, you know, like your nitrates, sulfates, there's others. I mean, think about that list that you have on the back of the periodic table. Any of those polyatomic ions, they were a compound that had already started to form, but it was not happy. It had not fulfilled the octet rule. It was not completely happy. It's why it had a charge and still wanted to bond with something else. All right, so ions have a charge. Okay, so if I have something like KNO3. Hey, hold up. Let's not do that one just yet. Let's do a 2 one. Let's do hydrogen with chlorine. Okay, so I told y'all hydrogens are always going to have a +1 charge. So +1 charge. How many of them do you have? 1. So altogether, I have a +1 charge. Now, this is a compound, so altogether it has to be equal to 0. So what +1 will give me 0? -1. There means there's only one chlorine, so this has a -1 charge. This is what you want to look at when it comes to those oxidation numbers. All right, so let's do another one really fast. Let's do SO3. All right, so oxygen we said is almost always going to have a -2 charge. I don't have hydrogen, so the next one up to bat is oxygen. So -2. How many of these oxygens do you have?
3.
3. So this would be a -6 charge altogether. Now, since this is a compound and this compound did not have a charge on it, it was a complete compound, we know that the charge is going to be 0. So what -6 would give me 0?
6. Positive.
A +6. So this is a +6 because there's only one of them. If I would have had 2 of these right here, then I would have had to take this 6 and break it into, you know, what's 6 divided by 2? It'd be a +3. But since there's only one of them, I can say the 6 carries all of that +6 charge. So that's what I'm going to use in a moment when I look at actual reactions. So those are your oxidation numbers right here. Let's do H2SO4. So let's look at something that has 3 elements in it. All right, I told y'all you're going to do hydrogen first. So what is the charge on hydrogen? A +1. So each hydrogen has a +1, but I have 2 of them. So altogether, what is this charge for the hydrogen? A +2. Now, since this is a compound, everything has to add up to 0. Okay, for oxygen, what did I say the charge would be? A -2. So what is 4 times a -2? A -8. Okay, so what is 2 minus 8? -6. So what -6 will give me a 0? A +6. I only have one of them, so this one sulfur carries all of that +6 charge. And these numbers right here are what I would use in a moment to figure out what was oxidized, what was reduced. Okay, what about this one? Do I have hydrogen? No. So then I'm going to go with your oxygen. Now, there's one of 2 ways that you can look at this. The fact that this is group 1, I can just go ahead and say it's a +1. However, we can also break this apart into your polyatomics, just like we could have done it right here, breaking apart into polyatomics. Guys, let's actually redo this one first, and then I'll come to potassium nitrate. All right, so this right here is a polyatomic. That means it already has a charge. Okay, does anybody remember what the charge is for SO4? -2. And if you didn't know that, well look, you know hydrogen is a +1, that's your cation ion, so this would have given you a +2. That means this whole thing right here, this whole polyatomic has to add up to a -2. That way it gives you 0. So if this whole thing right here, the SO4, has a -2 charge, I want to figure out what each of these different things are. So 4 times a -2 would be a -8. So what -8 gives you a -2? A +6. So you could have done it both of the different ways. I think on the video it only showed you this way, the way we did first. But if it's something that is really tricky, like if I have K potassium thiocyanate, KSCN, that was going to be a hard one to figure out. But you could break it apart. I already know what potassium is. It should have a +1 charge because it's in group 1. SCN would have a -1 charge altogether. And then you can kind of work it out that way to figure out what each of these different things are equal to. Okay, let's do potassium nitrate really fast. All right, so I could do it the 2 different ways. I could do each individual one, or I could say, okay, well, this is a +1. That means this whole polyatomic, the nitrate, is equal to a -1. That way, altogether, the compound equals 0. This is a +1, so this gives you 1. Altogether, this gives you 0. So that means if that's a +1, this has to be a -1, which is your charge for your nitrates. All right, we know oxygen should be a -2, so this would be a -6. So +1 minus 6 would be a -5. So what -5 would give you 0? A +5. That means this nitrogen right here would have a +5 charge. What if I have S8?
0.
It's an element technically, because it's just the one thing, so it would have a charge of 0. How about if I have,
Can you do the ALNO3 one with the parentheses?
give me 1 second. Let's do ClO4 negative. All right, so this right here is a polyatomic ion, but sometimes you'll see this one thing right here floating around. So I want to figure out the charge on every single thing. So would we set this equal to 0? No, we would set this right here equal to a -1 charge because this is not happy. This is a polyatomic ion that still wants to bond to something else. So I would set everything here equal to a -1. So I don't have hydrogen, so the next one I would look at is oxygen. This has a -2 charge. So 4 times a -2 is -8. That means this right here has to be a what? A +7. I only have 1, so it's a +7. And those charges right here are what I'm going to use in the next little step. H2O versus H2O2. So these are compounds. What am I going to set them equal to? 0. So it's going to be set equal to 0. I always say start off with hydrogen first. So this is not bonded to a metal. So you know it's a +1, so this would be a +2. What does this have to be? -2, so this would be a -2 charge. But let's look at this one. This is hydrogen peroxide. And so +1, so +2. What would this have to equal to? -2, so what would this oxygen be? -1. Good. So if I notice, I've got different oxidation numbers for each one of those oxygens. There's another one I was going to do with y'all. Oh. LIH. All right. Here, I've got hydrogen bonded to a metal. And so, guys, think about the charges that metals have. Metals are on the left-hand side of the periodic table. So what kind of charges do they typically have? Not typically. What kind of charges do they have? Positive. So in this case, hydrogen would not be positive. In this case, hydrogen is going to have a negative charge because it's bonded to a metal. So we know hydrogen in this case would have a -1. There's only one of them, so it's -1. So what would lithium have to be? +1, and so this would be a +1. And we know that because group 1s are always going to be a +1. Okay, now what was your question, Sierra?
The ALNO3, but it's like in parentheses, the NO3 is and then a 3 after it.
AlNO3. All right, so we got this because we crisscross charges. Aluminum had a +3 charge, nitrate is a -1. Guys, when we talk about those charges and when we do our crisscrossing, a lot of times they'll match up to these oxidation numbers. Sometimes they won't though. All right, so if I have this one in particular, I've got 3 of these NO3s. And so this is a -1 charge altogether. Each one of these is a -1 charge technically. So if I've got 3 of them, what is this equal to? -3. So what is, sorry, this would equal to a -3. What does this have to equal up to?
+3.
So aluminum would have your +3 charge. I only have 1, so aluminum is a +3. All right, so each oxygen is a -2, so 3 times 3 is what? 9. So 9 times 2 is? So in this particular case, everything adds up to a -3. So I'm gonna go right down here. -18 is equal to -3. All right, so what does this have to be? What minus 18 will give me a -3?
15.
It'd be 15. I have technically 3 of those nitrates, so it's 15 divided by 3. 5. So this would be a +5 charge for each one of those. Do y'all understand this? Okay, so when we talk about some of this, let's now apply it to your actual redox. So let's say we have sodium plus, let's try to make this kind of easy. Let's do silver chloride. I know it's AgCl because Ag always has a +1 charge. There's no exception to that rule. Chlorine's in group 17, so it has a -1 charge. When I crisscross those charges, it's AgCl. All right, so this is a single replacement reaction. We have to look at the activity series to see if this will happen. Sodium is higher up, so therefore it can shove. Remember I was talking about that? Since it's higher up, it can actually shove silver out of the way. So chlorine would prefer to bond with sodium because it's higher on that activity series. All right, so now silver is going to be by itself, and now sodium's going to bond with chlorine. So +1, -1, when I crisscross it, that right there is your compound. So let's go along, and now let's assign actual oxidation numbers to each one of these. So anytime you have a element, what is an element's charge going to be? 0. So this is a 0, and this right here is a 0. Okay, so now I've got these compounds. I want to see what the charges are, because at this point they've either given up electrons or they have accepted electrons, so their charges are going to vary. All right, so with this right here, this is going to have a -1 charge, and this would have a +1 charge. In this particular case, it's group 1, so this would be a +1. It has to add up to 0, so this would be a -1 charge. Okay, is there anything that did not change? Chlorine. Chlorine did not change. It had the same numbers on both sides of your reaction. And so I'm not going to look at chlorines. I just want to look at these two that did change. So let's look at sodium. Sodium went from having a 0 to a +1 charge. And then silver went from having a +1 to having a, what charge? A 0 charge. Okay, so I want to figure out what was oxidized and what was reduced. So you have two phrases. You can either say, Leo the lion goes grr. So Leo goes grr. Do y'all remember from that video what that meant?
No.
Okay, this means loss of electrons is oxidized. And this is on that handout that I just gave y'all. Gain electrons reduced. Now, that's how I was taught whenever I was in college. There through ASU, that's what they said. Leo the lion goes grr. That's the way I always learned it. And actually, that's what I use majority of the time still. Now, with my first year teaching, I had some kids that were not nice at all. And I was trying to show them, okay, Leo the lion goes grr. And they're like, oh, really, miss? We're an AP Chem, and that's what this is college Chem. I'm sure ASU taught you that, but is that what Harvard uses? So I actually got online. Harvard uses oil rig, and this is what everybody uses. Everybody uses one of these two mnemonics, and it's okay to use mnemonics, even in a college class. It's not bad. So oil rig, it means the same thing. So oil rig is oxidation, is loss, and reduction is gain. So it doesn't matter which one of those two you use. It's really, really universal. So don't think just because you're taking a college class that you cannot use mnemonics. Some people use even Elmo. Elmo is, I saw it just the other day. I don't remember exactly what Elmo stands for, but there is another phrase, but these right here are the most common ones. So on your little handout, let me see a handout really fast. That's what I put right here at the very top of it. I put Leo the lion goes grr, and I put oil rig. So use this little handout. It's going to help you out. All right, so when I talk about this right here, it's just the movement of electrons. That's all this is. And so think about it. Electrons are the only thing that can change. If I change my number of protons, what happens?
New element.
I have a new element. If I change the number of neutrons, well, the mass is just changing and you have an isotope. So what is occurring right here is the movement of electrons. And so guys, look at this. I went from 0 to +1. So I became more positive. If I become more positive, is that because I gained electrons or lost electrons?
Lost.
Electrons have a negative charge. It's because you lost electrons. That's the only way. I lost some of those negative charges. That is the only way to get more positive is because you lost some of the negative charges. So if I lose electrons, that means you are oxidized. So sodium right here is what is oxidized. And let's just double check it. Look, I became more And think about your number scale. You've got +1, +2, -1, -2. I went from a +1 to a 0. So am I becoming more positive?
Yes. Oh no.
No, I'm becoming more negative. I went from +1 to a 0. So I became more negative. What's the only way to get more negative in charge?
Sorry, I didn't get
It's to gain electrons. So if you gain electrons, that is what is reduced. Okay? So I know that sodium was oxidized and silver was reduced. So that's why I like to use Leo Gosger, and I'll write that at the very top of my paper, still to this day. I don't use oil rig as much. Now if you look, I've got both of those two signs in the very back of the classroom. They've been there all year long, and that's what that means. Okay, so you just have to know how to use it. So if sodium is what was oxidized, that means over here I can say sodium was oxidized, and silver is what was reduced. Is everybody good with that? Okay, so now we have something called the oxidizing agent and the reducing agent. And so I can call this oxidized and I can call this reduced. So think about it. This was reduced. That means the silver over here, guys, look what happened. It gave up an electron. But where did that electron go? Sorry, it gained an electron. Where did that electron come from?
The Na.
It came from the Na. So this silver caused the Na to give up an electron. So that silver causes your sodium to become oxidized. So over here, if this is reduced, then this silver on the left-hand side of the arrow is called the oxidizing agent. So if it's reduced here, then that silver on the left is called the oxidizing agent because it's going to cause that sodium to give up an electron to become oxidized. Now, this is what's oxidized, and so the sodium over here would be called, think of the opposite. If it's oxidized on the right, then this is going to be called the reducing agent. And this is where it gets a little bit confusing because once you figure out these two things here, then over here it's just the opposites. Because this is going to cause that silver, it's going to cause it to lose an electron. So therefore, since it's getting oxidized, we're going to call, it's going to cause the silver to gain an electron. So because of that, you're causing, it's going to be called the reducing agent. So look, sodium right here, and sodium. So if it's oxidized here, you call it the reducing agent. Silver was what was reduced, so on this side you call it the oxidizing agent. Do y'all understand that? So that was that last part of that worksheet that some of y'all were a little confused on. Okay, let's do another one. Oh, let's see. Let me look at an example. Let's say you have Cr2O7 -2 plus 6S2O3 -2 plus 14 hydrogen. It's going to give you 2Cr plus 3 plus 3S4O6 with a -2 charge plus 7 waters. Okay, so in this particular case, you had a net ionic equation. So remember, what happens in net ionics? Do y'all remember? This is one of those things that we got to start remembering.
Change, you cancel it.
Right, so you split apart anything that is aqueous because aqueous means it is a compound that was dissolved inside water. So we go ahead and split them apart to show that they were dissolved. And when you do, you write them with their charges. So anything right here with that little charge was something that was aqueous inside water. All right, so this is showing that net ionic. So I want to go ahead and try to calculate what the oxidation numbers are. I want to see what is actually changing. Okay, so this right here It was your anion. It was a polyatomic that had a -2 charge. So everything here should be adding up to -2. So if this is a -2, -2 times 7 is what?
-14.
-14. What minus 14 gives you a -2?
Plus 12.
A +12. Now there's 2 of them, so that means each chromium is going to have a +6 oxidation number. Okay, I don't care about the top thing anymore. I just worry about these oxidation numbers. Okay, so now let's do this one. Everything here should add up to a -2. Okay, so we know what oxygen is. So -2 times 3 is going to be a -6. What minus 6 will give me a -2? A +4. But there's 2 of them, so each one of these sulfurs should have a what charge? A +2. All right, and then look, this hydrogen, if it was just regular hydrogen like H2, I could put a 0 on this. But this had been some type of polyatomic, a compound that we split apart in the aqueous solution. We canceled out those spectator ions that were the same on both sides of the equation. So in this particular case, what would my charge for hydrogen be? A +1, because it has a +1 charge. Same way with chromium. What does chromium have right here? A +3. Okay, let's look at S4O6. So everything here should add up to a -2. All right, so this right here would be a -2 times 6 is a -12. So what does this have to equal to? Do what? Okay, let me make sure I wrote that right.
I had to do +2.5.
It shouldn't have a 0.5. That's my problem. This is a +1, -2. I don't think that's right. Let me double check it, but I don't. We'll go and put it down as 2.5, but I know that is wrong. I know that that's wrong, because you never have a 0.5 for a decimal. So that was question number
5 and 6.
5 and 6 on your homework. All right, so that is assigning your different charges. Hydrogens did not change. So hydrogens did not change. Your oxygens were all -2s. And so none of them change. This is why I will probably go ahead and omit number 5 and 6, because you cannot have that for your sulfur.
Do 7 and 8 too.
No, I'm going to do number 7, because that's what I did with the class yesterday. You know what? Let's omit number 5 and number 6. Don't do those 2.
Well, isn't the CR the one that's reduced though?
Well, okay, let me rephrase that. I guess you could, because you can tell with chromium if it's getting reduced or if it's getting oxidized. What did chromium go to?
It went to a +3 from a +6, so it was getting an
+6 to a +3?
Yeah.
Okay,
it
so
would be
listen,
1.
you can go ahead and at least do that, because it's not as positive. So what did it do to become not as positive? It gained electrons. So therefore, this is reduced. So I mean, if that's reduced, and that's what question number 5 is asking about.
And then
Already
number
marked out,
6
not
is
doing
the
it.
same. Because number 6.
And if it was reduced there, then, hey, no, I'm not going to omit number 5 and number 6, because you can at least listen. You can at least figure out the chromium. Now, I'll fix that problem for next year, but you can at least figure out that chromium was the one that was reduced. So if it's reduced over on the right-hand side, that means the chromium on the left-hand side is the oxidizing agent. All right, so let's look at number 7. Okay, so I have 14 hydrogen plus Cr2O7 -2 plus 3 nickels. It's going to give you 3 nickels with a plus charge, +2 charge, plus 2 chromiums with a +3, plus 7 waters. Okay, so at this right here, I want to go along and start assigning anything. So my first thing I always do is look for elements. Do I have any elements here? Yeah, I do. Technically, this is an element. Now this element has a charge because it had been bonded to something else. And then that other thing was probably canceled out in your spectator ions. So this hydrogen has a charge of +1. You know, let me write that charge with a different color. That might make it a little easier to see. All right, so this charge right here is a +1. All right, what would nickel be? A 0. This nickel is a +2. Chromium right here is a +3. All right, so everything here should add up to -2. So -2, this would be -14. So what minus 14 should give me a -2? +12. Now I've got 2 of them, so that means this would be a +6. All right, so now I'm going to come over here. Hydrogen is what I always start off with first, so +1, so this would be a +2. This has to be a -2, so it can add up to 0. I only have 1 oxygen, so this would be a -2. Okay, is there anything that is the same that does not change?
Oxygen.
Yeah, oxygen and hydrogen. So I'm going to go ahead and not look at oxygen, and you don't have to scratch it out. Sometimes I do if I'm just looking at redox, because just be careful on FRQ questions, because you might have to use this equation later on. But sometimes I will rewrite it like this so I can scratch it out so I can see what is actually happening. Sometimes I don't. All right, so what's changing? I have chromium that's changing, and I have nickel. All right, from chromium, it is going from a +6 to a +3. And for nickel, it is going from 0 to a +2. Okay, so look, it's going from a +6 to a +3. So I'm not as positive. I'm going from like a +6 to a +3. So I lost some of that positive charge. How am I losing some of that negative charge? By gaining some electrons. So remember, Leo Ger, if I gain electrons, I am reduced. So this is reduced. So this should be oxidized, but let's check it. I became more positive. I went from 0 to a +2. I became more positive. What's the only way to become more positive? To lose those electrons. So it's kind of the opposite way of thinking. So if I lose electrons, I am oxidized. Okay, so that means on the right-hand side, I'm going to write reduced and oxidized. So chromium right here is what is reduced. And nickel is what is oxidized. All right. So now I'm going to go to the left-hand side of the reaction. If I look at nickel here, it was oxidized. So what do I say that this is? This right here is going to be called the reducing agent, because it is going to cause the chromium to become reduced. It's going to cause the chromium to lose an electron so that the nickel right here can pick it up. Oh, sorry. It's going to cause, sorry, I said that wrong. It's going to cause the chromium to gain an electron. Is going to cause the chromium to gain an electron. And so that's why we call this the reducing agent. So if I look, chromium ended up gaining electrons. So if it's the oxidizing agent right here, then here it's going to be called the reducing agent. If this is the reduction, what would I call this compound? The oxidizing agent, because it's going to cause nickel to become oxidized. It's going to cause nickel to actually lose those electrons. Do y'all understand that a little bit more? And that's what the bottom part of that handout is talking about and showing you a little diagram of oxidizing agents and reducing agents. All right. I was going to go into how to balance half reactions.